Okay, Algebra 2, we're going to be working on our first practice test, or our 8.1 through 8.3 review. This is pretty much exactly what your test will look like. It's perfectly paralleled. Calculator use is really going to help you out a lot. Take a look at your first graph. You could definitely type this in exactly as you see it, 2.5 times 2. Make sure you hit this exponent button right above the division symbol. And really just going to your window, going to your table is most helpful. Second graph, you can scroll up very quickly to see the values that you're asked for from -3 to 1. Don't be afraid that there are some decimals here. That's going to be very typical. So at -3, we're at 0.3125. At -2, it looked like we were at 0.625, if I remember right. I think that's correct. Then 1.25. At 0, we'll be at 2.5. And when we have 1, you'll be at 5 itself. Now, of course, you can definitely get a graph as well just by pressing the graph button. And you can see this would indicate growth. Our 2 to the x, our 2 here is larger than 1. So our curve is going to be increasing. One thing that I do think is super important, all teachers are going to be reinforcing this, is always write in whatever is added next to the exponential part. If there is no number next to it, it's a +0. What we're looking for on this test is for you to show that horizontal asymptote. This is where your curve will flatten out. So even though it is on the x-axis, it's very important to write down this dotted horizontal line at y equals 0. We'll go 3 to the left and move up at about a third, 0.3 is maybe about right there. At -2, we're a little bit higher than halfway. You don't have to get it perfect. At -1, we're at about 1.25. At 0, we'll go up to 2.5. And at 1, we'll go 1, 2, 3, 4, 5. You already saw the shape of that curve. Make sure you do connect it. If you're not connecting it, you won't get full credit for your graph. But you know it should have this general type of a shape. The next problem is amazingly close to this. And in fact, we can, just as we'd spoken before, realize that we have a +0. We don't have an addition or a subtraction after that. So please do immediately draw in that horizontal asymptote, even if it is the x-axis. On the test, it might not be there. It might be raised up or lowered. But very quickly, you can see with the calculator really doing all the work for you, that can be so helpful. If you want to see fractional answers, you can have alpha y equals. A number of kids have spoken to me about how they prefer to see decimals. If you'd like to see decimals in your table, just hit 1 divided by 2, and then raise it up to the x. From here, just hit second graph to go to your table. And you can see at -1, we're going to be at 6. At 0, we're going to be at 3. At 1, if I'm remembering correctly, I think we're going to be at 1.5. And at 2, we're at 0.75. And then at 3, we're at 0.375. So once again, the calculator gives this information to you pretty much instantaneously. When you hit graph, you'll see a different shape. You're going to notice that really a base of the exponent is a number smaller than 1. So this is a decay graph. Our curve, as we go from the left to the right, moves down. So plotting this out, I'll go 1 to the left, 1, 2, 3, 4, 5, 6 steps up. At 0, we'll just move 3 steps up. At 1, we'll go 1.5. At 2, we'll move up about 0.75. And at 3, roughly about there. You can connect, and definitely need to connect this, and show your curve is going to be leveling off at the x-axis, and it won't touch it actually. Number three, definitely want to point out that you'll be asked about transformations and how a graph is moved or translated to a second form. Y equals 2 to the x is the parent function, and it's actually graphed down below in part B. But if you were to look at this change, 2 is raised up to the x plus 1. This is what we call x files because our plus 1 is directly next to the x. The plus 1 is written up high as an exponent. Remember the TV show X-Files, it's even airing currently, is all about the paranormal, very weird stuff. If you see a plus 1, you think you're going to move in the x direction. X is right or left. Plus 1, you probably think you're going to move 1 to the right, but this is X-Files with reverse logic. So we're going to move 1 step to the left. You look at that minus 3, and that's not affecting the x, that's away from it. So this will be a movement up or down, but this is ordinary logic. When you see negative 3, we'll say 3 steps down. Now, when you're graphing, and you're going to have to graph, to receive full credit, you're not only going to have to move some points, and that's what this is saying, must move and plot at least 3 points. Very, very, very importantly, you need to show that horizontal asymptote, just like we were doing up above. The horizontal asymptote, and let's even address that at part E right now. Whatever number is added or subtracted, that is so critical. It tells you where your curve flattens out, and it's going to be at y equals negative 3. So we can move 1, 2, 3 steps down. It is a good idea, and I highly recommend that you even start doing the graph with that horizontal asymptote. There is that flattening out. Now find 3 friendly points, like this one, and perhaps this one. When I say friendly points, I mean points that are clearly on the corners of these little squares. And you choose these because following this transformation of movement, you can take these friendly points, go 1 to the left, go 1, 2, 3 steps down. So this first point on the y-axis is now down here. Take a look at this point right up here at 1, 2. We're going to go 1 step to the left, 1, 2, 3 steps down. Finally, we'll go up here to that point at 2, 4, it looks like. That's 1, 2, 3, 4. But we'll go 1 step to the left, 1, 2, 3 steps down. These 3 points that you see here are actually going to be your new curve. By the way, your calculator will give that information to you. You could find some friendly points if you wanted to on a table, but it's honestly quicker for you to just graph it this way. The domain for all of these curves will always be all reals. In your range, if you look, your curve is above this flat horizontal line, so you could just write y greater than negative 3. And we're going to wrap up our video here. We're going page by page.